And now it's time for a Geek Speak with
GK Technologies,
Sarah and Jody.
In the fields again. I just can't wait to get in the fields again. The life I love is spreading potash for my friends, and I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Welcome back to A Geek Speak. We are excited to have you back again. Actually, we just had to start recording this because we were having a riveting conversation before we started recording. And I'm like, we need to stop and we need to start recording because this is a great conversation that we are having with Shawn Kasprick from Simplot again today. So if it's all right with you guys, we'll just pick up kind of where we left off there before we hit the go button and just start talking about the practicality of fertilizer application out there in the field. So one of the things at Simplot is your business has the precision agriculture capabilities, the application capabilities, and the fertilizers. So you can see it all the way through from start to finish.
Right. Yeah, we've been able to do it. And that was one of the things, even within the, when we were dealing with precision ag, we could take it all the way from the farm, grabbing whether it was yield maps or satellite imagery or whatever, bring it all the way through. We have the application equipment to turn around and make that application out to the field. We had the fertilizer, so we just had to make sure everything lined up. And if anything has changed or somewhere in midstream or the next day we have to make a change within the map or some new information comes in, we can make that change within a few minutes and be done and move on with the field. Not a big deal for us.
That is a pretty big deal to have that capability to do that. And you've been doing this for a number of years. So you've seen about every single kind of fertilizer spreader, because you must make maps that actually your customers, your farmers will apply as well, right? Yes. So you've seen about every single kind of variable rate controller out there in the marketplace.
Yes, there's been plenty of them, and some that are really fun and easy to deal with, and then some that you're like, all right, hopefully he upgrades, and so we don't have to deal with that one again.
And just to put things into perspective, he was talking about exporting to a Falcon 1 on a 3x5 floppy disk. Yeah. So he is he does understand the older technology.
Yeah, and there was some old ones out there, even some of the old Rockwells. We had done some of those, and those were down in Nebraska, so they were far and few between. But there was still a few people who dealt with Rockwells. Some of the neat things that we had to deal with on the higher end was probably in the northwest quarter of the U.S. is how do you variable rate on orchards?
Oh my gosh, how does that work?
So there's a little tiny spreader that'll go down in between orchards, and so you take all of that information and you just make it on a smaller scale. And that's all it is. And so you're dealing with orchards. Agronomics are still the same. You're still having to deal with NPK. You're still, it's just a little different application method, but the agronomics are the same.
So if you're going between trees, I'm just trying to visualize this. Realize I'm a wheat farmer from North Dakota. Okay. So for all of you people out there from California listening to this. So you're going between trees. Do you just have like a narrower swath that you're actually doing so you don't apply to the whole field, because theoretically the fertilizer is going to get down to the roots of the trees in the row, or like?
Right. Yeah. So that absolutely. So they've got their application equipment. Think about it like a pull type little buggy spreader, spinner spreader type of idea. And you just kind of have walls on that so it doesn't spread over top of anything else. You just have it contained between the rows. As the roots grow out to it and are in between the rows, that's what they'll go ahead and grab a hold of it. But you're just spreading in between the trees and not having to throw it all over the place.
So when you make a map, you probably just like make a map like you would like a zone map. And then their mechanical side, like their spreader, that's what they'll just follow the map. It'll change when it hits the new, grid or like area that it goes through with the rate. Yes. But then the mechanical part will just keep it contained between the rows. I mean, that takes creativity, right? Like there's a piece of creativity to think about, okay, what are the basics what am I trying to accomplish here? And then how do I like make the software and the mechanics talk to each other and make it work?
And that's interesting from a standpoint that, one of the things that a lot of our customers want to see at the end of the prescription is how much fertilizer does this field need? So how do you compensate for that? If you make like a fertilizer map over the whole thing, but it's like, we're not going to need.
So you still need that fertilizer because a crop still requires that much nutrients to go through it. You're just not applying it all over the place. You're just applying it specifically between the rows. That's it.
Okay, there it is. Okay, I don't know if people have the ability with their imaginations to see this podcast right now, but the light bulb just came on for me.
I can confirm there was a light bulb. So, I mean, when I think about this and when we were talking the other day, Shawn, I think creativity is such a huge part of map making and making these precision ag products. You know, what are some things that you can think back on in your career of like, I really had to put my thinking cap on to solve this problem and make a map that works for this customer?
Well, of course, we kind of touched on it in the last episode where we were dealing with dual, and you looked at the organic matter, and it was low, medium, and high. Okay, how much organic matter is low? How much medium is medium? So you had to think that through a little bit, and so you call up the reps or the tech reps and ask them a little more specific questions, and they usually pull it on a little bit higher level just to understand what in the background, what is driving that information. So that was one of the first things that we kind of came up with and kind of played around with, was looking at doing variable rate soil residue or soil applied herbicides. You start looking at the next couple of things that we're doing. I mean, how about pH? Does pH affect the herbicides? Absolutely. And do we see differences within soil pH? In the valley, not so much. You start getting outside of that, and the ridge tops, the eroded knobs, you get the deposition within the bottom swales and the foot slopes and everything else. So there's a lot of variances that are out there.
So have you had the opportunity to create variable rate residual herbicide applications?
Yes.
Awesome. Can you tell us about it?
Well, it was starting with dual, and we just made those simple maps, and it was based on our guess within our best guess, and as well as that our sales rep for that chemistry had to come in, and we had to make sure that they would still understand what we're trying to do. Because when this was first going on, we're like, okay, well, worst case scenario, this area may not get enough soil residual that we need to do something different. So, but if you get the rep involved and they start to understand it, or the tech rep, and they're like, yeah, that's absolutely a great application, and we'll back that. That's where we had to kind of start.
That's a big deal if you get the chemical, especially the tech rep, to back it. That's pretty amazing.
What was your goal with it? Like, were you trying to save costs? Were you trying to avoid crop injury? Like, what were you going after with the application?
Originally everything started with, can we save cost? But, that's great. And that could be an application, the application of I want to save cost, but at the same time, I don't want that soil residual to go beyond the date, because I still want to plant sugar beets there next year, or dry beans, or whatever crop it is. I want to still be able to plant that next year. So I want to make sure that I'm doing it correctly. The other flip side of that is the operator and the equipment. Do you have the application equipment to do those applications?
And that's what I was going to ask. Were you actually variable rating the volume of the solution to accomplish your residual herbicide application? Or what were you actually variable rating?
So the grower had on their sprayer, they were doing the application. It was just I think at the time it was a Raven applicator. You just go through and it changes the whole volume. I mean, instead of doing 20 gallons of water, this area is only getting 18 gallons of water, and this area is getting 15, and that's enough to vary the rate for what we were looking for at the time. But that's what we were kind of getting into.
Absolutely. So it was an actual variable rate of the gallons, the total gallons of solution per acre.
Yes.
And thereby variable rating the active ingredient.
Yes.
As a weed scientist, I think it's important. We've talked about it already, but this is a residual herbicide, right? So we don't care so much about gallons per acre is still important, but less important for residual applications to the soil versus to the crop.
Yeah, because I still had to do an incorporation event, right? I mean, there's still some things that had to be done anyway, so it's not like we were completely missing anything. It was just a little variance in the application and the active.
And we'll talk about this on other podcasts coming up with some other guests that we've got in mind. But one of the things that is interesting when you think about variable rate pesticides is, especially herbicides, is the post versus the pre-applications when you're actually dealing with weeds that are emerged versus not. That coverage component of a weed that's emerged is way more important than trying to get your coverage on your soil for just a soil applied herbicide. You got to be careful with that. I mean, if you're going to only apply 2 gallons to the acre on a residual herbicide, I'm not going to recommend that as an agronomist. But, if you're varying from 10 to 20 gallons per acre, you're going to be fine.
Right. Absolutely. And I mean, there's some different applications. I know, Jody, you and I were talking about this a little bit where we had a satellite imagery where we were going to do take monthly pictures of the crop, or I can't remember if it was monthly or every other week or whatever it was. But the first time that they started, we had to, of course, program that in and schedule that with the satellite company and get that all going. Well, we ended up, the first image that we got was, the crop really wasn't up, or it was just barely cracking the ground and it wasn't emerged. But we were looking at the image, and the image came back and it showed green and there's growth in this area. You're like, what is going on? Okay, we're not picking up, soybeans just cracking and emerging out of the ground. So we go out there and actually ground truth the field, and that was with wild oats. The wild oats were already merged and showing up. Well, and it's soybeans and it was Roundup ready, and so we didn't really care at the time. But the grower was kind of challenged us and looked at it, and the following year, he was going to be raising wheat.
All right.
Trilate, the Fargo herbicide, Trilate. So you go out there, and this area of the field was our seed bed. It had plenty of seed and wild oat seed in that seed bed. So we would make the applications of this area would get Fargo, this area would not, and that was one of the easy ones, right?
And I still think to this day that is one of the coolest ways of using precision agriculture, when you can variable rate that wild oat application in wheat. Oh my gosh, that's pretty fun. Did it work well?
It did. It really works well, and I know we're still doing it to this day. That customer, if we know those fields and things that were going on, we'll do that.
And just to take a step back again, one of the keys to that is to make sure that you can accurately identify where those wild oat patches are occurring. And so sometimes that's easier to do in a later seeded crop, not necessarily when the wheat is actually growing out there that year. You want to plan ahead for that year when you're going to be raising something like dry beans or soybeans that's later planted, and then get those wild oat patches mapped from the satellites, if I'm hearing you correctly.
Correct. Yeah. Or, there's this, I kind of want to joke around a little bit that this is some novel idea, but you think about what does our yield monitors do? What is one of the other applications of our yield monitors? You can mark specific things that are going on that you see in the field. Mark a rock, mark a something that you have to come back to and deal with. Well, if you set it up where you're marking all your wild oat patches, you could be doing it that way. What if you're marking all of your Canadian thistle patches that are going on in that field? And if you mark it this year, is it the same patches next year? Okay, well, what can we apply that will just specifically take those out and target our applications for those crops or for those weeds?
Okay, so I have to shamelessly plug one of our new products right here, because if you were to carry your iPad with and you have the GK Field Mapper app out there in the combine, you can mark all of these things very fabulously and then send them seamlessly back to your ADMS software.
This is such a putting my farmer hat on, right? When I think about precision agriculture, it's all about interpreting that firsthand knowledge of your fields, right, and making it into a map. And what the point I'm trying to get at is me or my dad going across our fields, like, we know exactly where those patches are. But like, if you were to like say, okay, well, get me within like 100 feet of the patch, that might be a little bit more difficult going to like a Google Earth and pointing those out. But when we have those exact pinpoints when you're in the field, it makes the mapping so much easier. Like you get more confidence that your application is going exactly where it needs to be. And that's That's so exciting because like that's one thing you kind of just forget about sometimes. Like you know where those problems are, but until you get out and like map and put the precision location on it, it can be hard to manage.
And it could be a lot of fun, actually, if you're in the combine and you mark those spots, and then you have those spots in your precision agriculture software, and you overlay it with early season imagery, so you can verify that that green spot that's there before you plant is in fact your wild oat patch. Right. That's fun.
You know, and I know we've talked about it before, and they brought it up. I'm sure Dr. Goose has brought this up on a couple of different applications and things like that. So what about iron chlorosis?
You know, we've had a lot of conversations about iron chlorosis, obviously, within this company. And obviously, that's very near and dear to my heart. I know that you as well, Shawn, have worked with iron chlorosis quite a bit. And so, I mean, NDVI is a nice way to describe that, right? Are you using NDVI to describe where the iron chlorosis spots are happening in a field?
Yes. And I mean, you know, you still have to look back at what is that satellite imagery telling you. It's just telling you it's a lower productivity within the field. That's all it's telling you. So you still, and this is where people get the mistake. You still have to go out and ground truth that and make sure that that low spot isn't just a salty piece of ground along the edge of the ditch. It's actually iron chlorosis or what is going on.
And not only that, but in today's agriculture with soybeans, just because you get that yellowing going on, especially if it's later in the season, you need to go out and verify that it isn't like soybean cyst nematode or something.
Absolutely.
Or potassium deficiency. Like, I know they look different in person, but like on satellite imagery, we are seeing more of those K deficient fields late in the season.
And that's just it. I mean, all that satellite is telling you is that this area is low productivity or high productivity or whatever it is. That still doesn't tell you, oh, this is potassium deficiency and this is, that's where your diseases are. No, all it's telling you is low productivity and you have to go out there and ground truth.
And actually, it's telling you that it's less green than the rest of the area.
That's right.
And, you know, one thing that's always interesting, even if you're getting those really dark green areas, if something doesn't seem to make sense with your previous knowledge, you got to kind of be a little bit careful with that because well aware, especially if we go out like western North Dakota, there's places where you know it's not a good productivity area, but it's coming back green, but it's because of the weeds that are there. Right. And so, you know, you have to understand what's going on in the field. That comes back to you can look at data all you want, but you still have to be grounded in that agronomy.
Right.
Of what makes sense and the knowledge of the field.
Yeah. And I mean, you take a look at when we're getting into, you know, a single layer is not going to get you that information. So if you take a satellite imagery and you've got an area of we'll just call it low, medium, and high reflectivity and productivity within the field, what's causing the low? We just kind of talked about a couple of them where it's salinity, it could be iron chlorosis, could be potassium, a disease, whatever. What about on the high side? Well, this area is just generally high productivity. Well, what about those old yards? Okay, so if you get that satellite imagery that comes back and says this whole area is all high productivity, you're going to throw that all into one zone? Some people would, but what's the soil test coming back? And based on your background, the soil tests come back in those high productivity areas, typically is lower analysis coming back because that crop took all of that nutrients up to build that production and get that high yield, but that old yard is still there. That old yard is not is high productivity and high soil test.
Okay, so just had a light bulb moment. Speaking of like high productivity and those really like green areas, what have you done with like white mold variable rate? Like how have you used satellite imagery to like address those areas and do VRT that way?
That's a pretty good lead in because we just had that conversation here the other. So you start looking at the satellite imagery that comes in. Okay, what is that telling you? This area is, whether it be the NDVI, and this area is just high productivity, high crop growth, and this area is low crop growth, maybe poor yields, poor crop, maybe it's just drowned out in general, whatever. But look at the disease triangle. You need to have the disease present, of course, so you need to have a crop present, the host, and you need to have the environment. Okay, well, within that satellite imagery, if you don't have the host because it's drowned out or it's such a poor emergence or just poor vigor because it was salinity or tough conditions, well, that's not conducive to the disease. Okay, so you take a look at the other side of things, the environment, high crop growth, a lot of crop vigor going on, you're going to have a high disease pressure, or alongside the shelter belt where you just don't have the wind to dry it down and help you out there. So that could be your a high environment for disease risk as well. So all of that disease triangle, we start looking at a satellite imagery. If I could divide that up into areas that I want to have maybe my highest application rate, the highest rate of, say, a white mold herbicide in this area where it's drowned out and dead or whatever. I don't want to apply anything because there's nothing, maybe the yield's just not going to be worth it, but everything else in between. So you still have to do an economic rate to make sure that it works correctly. And if you look at a product like, say, Endura, for example, where you get 5 ounces or 6 ounces, that's a low to high rate. There really is not a whole lot of variance that you can deal with in there. But you look at other products that have, like the T-methyls, you go from 1 pound to 2 pound rate. Well, maybe that's a big change. And can I, in those areas where alongside the shelter belt or that just have such a high productivity where I'm going to get tangled up if I try and walk in there and ground truth this thing, I want as much protection out there as possible. So I want my highest rate. Okay, so can I do that within the application? Absolutely, you can.
Are you talking then again about on that T-methyl of coming up with a standard rate per solution and then varying your gallons per acre again?
That's right. Yep. Because we don't have an injection unit to be able to change that on the fly. And if you had an injection unit, which we did not at the time, but we could vary the rate. And again, if you are talking about going from a 20 gallon per acre rate down to, say, a 15 gallon per acre rate, you need to make sure you have the right adjuvants and things going on so you get good distribution, but you're still able to change the rate of the product and maybe you save yourself a little bit of cost and do the application that you know is the right thing to do out in the field.
So obviously you have been doing variable rate fungicides for white mold management, and so it's actually occurred. This isn't like a newfangled thing. People are actually doing it. What are the results? How do you think it's gone? Have your customers continued to do it?
Yeah, and then of course they go and trade off their spray equipment and didn't want to do it again. So there's things that are going to occur, right? Or their applicator, they got a new application, but they have somebody else running the applicator who's maybe not as tech savvy as you want them to be. So things happen. But we've got that capability, and it's really up to the customer to kind of challenge us and ask us, this is what our thoughts are. And as an agronomist, you look back and you know what, that makes a lot of sense. Let's do that. And within the technology, it's not a big deal for us to change the technology and make the technology. It's just make it work. But can the applicator do it? Do you have an application equipment that'll work? All that makes a difference.
For all of our growers listening, think about that. What are things that you've thought about that you could do on your farm that you could achieve with precision agriculture? Talk to your agronomist, talk to your consultants, talk to the companies you work for. Explore that.
Farmers are always creative. The farmers that I've known, they always are trying to think of ways to make things work with what they've got or just to do things better. So the creativity component within agriculture is there to make it happen. But if you ask a good question, just ask for help. That's just, and I think this is a great lead into my to a big question that I've got for everybody in the room. Where do we think precision agriculture is going?
So I've got a good lead in on that one. So I was at an Info Ag conference a number of years ago, and at that conference it was we were talking to, or one of the speakers were talking about satellite imagery, and he knew some people who actually look and pull in the satellite imagery and data analysis itself. And we're talking some high level stuff. So I'm guessing the NSA and things like that he have access to. But he was talking about, at one point in time, they were able to take in, zoom in, and identify, based on the satellite imagery, they were able to identify and read the license plate on a vehicle as it was going down, right? I mean, so you start talking about a little bit of high-end stuff.
Big Brother is watching.
Right. But then he goes, well, now we're able to identify the genus and species of the bug splatter on your windshield.
Holy Hannah, that could be useful.
And the guy was like, oh, that's pretty awesome. Those optics are really good. The guy goes, who said anything about optics? And then he said the guy dropped the conversation and that was it. And we're like, well, tell us more. And he goes, but the guy wouldn't talk to me anymore about it. He said he just left it at this hangar. And we're all just kind of drooling and feeding off of this going, wow.
Every day since, or every night since, Shawn has had nightmares about this technology. What are they using?
But wouldn't that be so cool? Like soybean aphids. I have this idea that I don't think we should have to walk the field for soybean aphids anymore. I think we should be able to get a picture. And I don't know if it's going to be a picture. It might be some kind of a sensor that is sensing something different. Right. And I would like to know if we can think outside the box and develop thresholds for soybean aphids that takes into account not only the population of soybean aphids, but also takes into account, I mean, if we're sensing stuff, let's sense the number of dead aphids that are out there. You know, the skeletons that are still exist on there. That's valuable data when you're scouting that. And how about the beneficial insects? If we can take into that account, we've got great weather sensing information that's out there already. We could really hone in some pretty amazing thresholds, I would think, for soybean aphid populations. And by the way, if we're doing that, why can't we figure out where in the field they're really high? Those populations are really high at threshold. And why can't we control them in that area rather than spraying the whole darn field?
Right. Well, and you think of where are drones going right now? I mean, we can send out drone swarms and go out there. Some of that doesn't ramp up for large scale, applications where I'm going to be able to scout 20,000 acres today. That would be way too much. But at the same time, can I go out there with some drones, some really high resolution, just photography, and get some information back? And maybe that's going to take a look at, I want it to go through these 15 spots within the field and run my analysis on that.
But if it's a drone swarm, why does it have to be a picture? I mean, if they're sensing the genus and species of bug splatter on your windshield, maybe we can do it with something else. I don't know what that is. Temperature. Maybe it's a combination of sensing the bugs that are not splattered and getting the genus and the species, as well as like the temperature of the plants. Maybe that's what the thresholds need to look like.
That's a crazy thing. I think with AI coming into the picture, right? We have the ability with drones now to take all sorts of information. So say if we've got a drone that's got thermal sensing and NDVI sensing and RGB cameras, maybe that combination of data and all the different data points that are coming out of that drone flight, maybe AI can help us develop those thresholds where we haven't been able to do that as humans before. And that's where I think about, where precision ag is going. I think about how the things that really help farmers now, farms are typically larger in scale. They've got less time they've got agronomists that go out and look at things. But I think anything that will give real-time feedback of what's going on and predict those things like aphids, like weeds, and bring that back and help identify right away where they are so you can make an application quickly. Those are the things that are going to take off. And I think AI is really going to play a big part in that. But we also got to figure out data storage and stuff and processing and all those other things. But we'll figure it out.
So
we've gotten here first.
Let's tie in a little bit of old technology and the new technology. Okay, so the old technology of the sweep nets, right? Well, why not have my drones go out and just run a course around this field along this edge, and this is what I want them to collect, and come back and take a look at it and go, oh, okay, well, I'm at threshold. Boom.
Boy, that's a great idea. And here's the other thing that I think the industry, for anybody that's out there in industry, kind of needs to think about. I think it's really easy to say, fly a drone over, take a picture, and use the data. You agronomists figure it out. But what's interesting about that is it would be really great if we could bring this down and realize that, okay, drones have been in agriculture for a long time. And I honestly think that they are going to be a huge part of what we do into the future. But I feel like we're waiting for that, the technology side, the equipment side of that, to hear about the challenges that agriculture itself presents. We need to actually take it down to, you can't just say weeds. We need to be able to identify weeds when they're very small, oftentimes even smaller than what a drone can actually take a picture of at this point in time. And so how do we work to think outside the box of, here's a picture, you agronomists go figure out what to do with this picture. We're going to have to think outside the box, and sometimes it's going to be right down to the species.
Absolutely. I mean, think back to our conversation with Travis Yike last year, right? Phragmites has a different ratio of chlorophyll A and B at different times of the year. Do the little seedlings have different ratios of chlorophyll A and B by species? Can we sense that as an NDVI sensor versus a picture, right? Like, I fully believe that we have the ability to collect the data. It's just a matter of like money to process and store that data.
So, and at the end of the day, and it kind of comes back to we can collect all this data. What are you going to do with it? If it does not give you a better decision to make or allow you to make a better decision than what you would have in the first place, doesn't make any sense to spend the money there. And that's what we're always, as an agronomist, you're always going kind of back and forth. Well, here's some cool applications, cool ideas. Is it going to make my recommendation better than what I was going to make anyway? Or is it going to save a little bit of cost up front? Is it going to make things speed up so I can do more with less? That's where we need to be. That's where we're trying to get to.
And I do think that the number one reason why the conventional crop scout that still rides a four-wheeler has not been replaced by drones, it's because you can still scout a field faster than you can get the data back and get it processed. And the crop scout itself is doing a more accurate job of identifying specifically the weed species that are out there at this point in time. And so until we really address those things and we get the signatures back for what a specific weed identification is at the proper timing for weed control, I don't know if we're going to be able to get to the weed control part. But again, AI and everything, I do believe that we will see changes coming forward with it.
Yeah, that time component, you're absolutely right. Like, to stitch together like a field of drone imagery, like if they're taking thousands of pictures of the field at really high resolution, that's going to take a lot of time to process. Whereas like you as a human can take a look at a lamb's quarter and within a second you can figure out that's a lamb's quarter. Let's not forget the value of our brains too.
We still, and I'm going to bring this back to the first episode where Shawn actually talked about his education. You still got to be grounded in those basics, the basics of what actual just crop production is. There's a way to put a seed in the ground. There's a way to do weed control. There's just some basics. How weeds work, how soils work.
And you look at that and, can I identify a lamb's quarter or the kochia or, I got water hemp in this field? So now you can identify that faster, but is it going to really change the product that you're going to apply later on? If it doesn't, because you're going out there and it's going to be, I'm going to be using, like when we're going with Roundup Ready crops. Well, I see this weed, I see that weed, I see that weed. What are you going to apply? Roundup. Okay, it doesn't make any difference. Right. Well, now if we need to go back and start to look at that, this area I really need, this product does a better job on this weed, and then over here the rest of the field I can go with a different herbicide. That can be done too.
That's such a great point. That's so right. It has to actually affect decision making. Like I TA'd weed ID in grad school, and if a kid didn't know what the weed was, their answer was, I don't care. Glyphosate can kill it.
Glyphosate can't kill it all the time. not today.
But yeah, I mean, that's such an important point to remember is like, if we have a blanket recommendation for whatever it is, then that value or that information isn't important. But if it can change our decisions or make it enhance our decision making and make it better, that now has value. So it's interesting to think about, okay, what technologies can we get to producers to enhance and bring that value?
This is just such a fun conversation. I feel like we could go on and on about this. So the three of us will run into each other at different farm shows and stuff, and we can stand there and talk for an hour easy, and we won't even know that the time has gone by because these are the things that we talk about. Yes, we are all a bunch of nerds in this room.
Yes.
And I'd like to say that we're proud of it, but I don't want to speak for everybody.
Oh, yeah. Absolutely proud to be that. Yes.
It's so much fun, but I think this is a pretty good place to wrap it up. Shawn, thank you for your time visiting. This has been such a fun conversation. I honestly believe that our audiences are really going to enjoy this one. But thank you so much for joining us. Shawn, you are at Simplot. I do want to, where can people find you if they want to talk to you?
Yeah, I mean, I'm at Simplot. I office up in the Grafton, North Dakota location. But I run around all the tri-state area here, North Dakota, Minnesota, South Dakota. Any of our Simplot locations would be able to get a hold of me. I'm always on a cell phone somewhere, traveling, or sitting in an office, sitting with any of our customers, our crop advisors, so they can get a hold of me pretty easy.
That's awesome. Again, thank you so much. It's been such a fun conversation. With that, at GK Technology,
We have a map
and an app
for that.
And I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.